Please welcome to the stage Black Hat founder Jeff Moss.
This is crazy. Awesome. This has got to be one of the biggest audience I think we've ever had. There's like 6,400 of you in this room, which is huge. And apparently there's an overflow room. So I want to try this. If you're in the overflow room, scream, and we're going to see if we can hear you. No. So welcome to Black Hat. This is our largest ever, as you suspected. And it's also a new floor plan. So if you were here last year, you're going to notice some changes. We put all the business hall downstairs, and on 2 and 3, you've got all the content. You've got the arsenal. You've got the career track. And then you're also going to have the Pony Awards up here later on this evening. And so for those of you who've been here before, I generally do some statistics, and I'm going to just throw out some numbers to give us an idea of what's going on this year. One of them is we give out scholarships to students who write white papers on security topics, and we get the submissions and we review them, and we accept. There's no cap on how many we accept. We only accept the ones that we think are interesting and some energy and some effort's been put into it. And this year we accepted 194 scholarships from students, which is a record number. So if you're a student here and you got a scholarship, raise your hand. Okay, so look around. If you see that, go up and congratulate them for doing it and kind of help them into the Black Hat world. We also have 108 different countries of the world represented here. And I used to read them all off, but the number has gotten so large, I could be up here for a while. There's 28 countries that have sent a single person. And I'm just going to name a couple. The Aland Islands, America Samoa, Macau, Kenya, Jordan, Iran, Yemen, Wales, Venezuela, Uruguay. What was that, Uruguay? Yeah. Excellent. Uruguay could probably use some security. So last year, this is also the biggest year, I think, for us in a number of reasons. I think we've got the most attention, the most eyeballs on us this year for a number of reasons. One is it's an election year. There's a lot of things going on with security around the elections. We had the OPM breach. We had a lot of businesses are focused more on this. They realize that their exposure. But we also have a lot of legal attention, from the CFAA to the Wassenaar arrangement. And so you have people in legal and policy areas asking us for advice. What does it mean? I'm really proud that it was the security researchers and the hackers that pointed out the problem of the Wassenaar arrangement, and then companies like Microsoft and Symantec kind of carried the ball. But it was us, it was our community that pointed out the problem. And so that shows that we have a vital role to play in this area. And then also now it seems like 2000s all over again, popular portrayals of hackers in TV and movies, right? We've got Mr. Robot. Apparently there's a new Jason Bourne movie, which is like DEF CON, but it's ExoCon. So we're back in the public eye. So it's really important that we take advantage of that, right? It's an opportunity and a curse. We can either really screw it up, or we can really be useful and become trusted and be used in all these new conversations. And last year I talked about complexity and how complexity is forever. How are we ever going to get off the complexity curve? And the only solution I saw was radical simplicity. And so this year I want to talk about speed. Speed, sort of a corollary to complexity. And there's technical speed, right? We're trying to move faster than the bad guys, compostable systems. How fast can we spin up a new deployment? If we were attacked, how fast can we react? Facebook with their app, how many people notice how fast that Facebook app is getting updated all the time? By about the time you reverse engineer that app, they probably have a new version out. Right? They're trying to stay one step ahead through speed as one of the strategies. Speed is also something that business people love because you can measure it. How long did it actually take? It wasn't a metric like how many times are we attacked, because you can't control that metric, but you can control speed. One of the biggest metrics I noticed across all companies now is time to remediate. When you notice a breach, now you might have been owned for like a year, but when you notice that you were breached, how long until you think you've cleaned up? Is it a week? Is it 5 days, 4 days? Really aggressive companies are at like around the 2-day mark. Really slow companies are, in the weeks. But it's a metric you can measure, and it's something that CEOs like because it goes on a dashboard. And so think about how you can use speed to measure what you're doing, and it's great to give incentives. Well, from the time we're notified there's a vulnerability in our production web server to the time we can report that it's closed, that's time. Let's measure it, and let's give rewards if we can find ways to shrink it. It must be like that at Google. It's like shave a nanosecond off of some query, and you get a car. You could incentivize people around speed. And I was at the CEO event. I was lucky enough to be invited to the CEO event that had the world's largest companies there, and I was speaking on security, and I was at the end of the day. So I sat around like a fly on the wall, and I listened to what all the CEOs and CIOs of these companies were talking about. And I expected it would be something like regulation, unions, problems with supply chain management, concern about third-party risk and vendors. No. Every single CEO and CIO said speed was their biggest concern. It was speed to market, speed to reconfigure their enterprise network to be able to better reflect like a mobile environment, speed to produce products, speed to react to attacks. It was speed. And I was stunned because I figured, speed will be in there somewhere, but it's at the top of the list of the largest companies. So if you're trying to sell to these people, if you're trying to speak their language, you want to put speed into your dictionary, because that's what they're thinking about. And I use speed and race cars as sort of an analogy. You put really big brakes on a race car so the race car can go faster, right? So think of security as we're the big brakes for the race car. We allow companies to take more risk. If a company can take more risk confidently, they can go faster. They can go into markets they might not go into. Imagine if you went to your CEO and you said, you know what, I'm so confident we can remotely deploy people into China. Right? That's a competitive advantage for some people. And so you could get a speed advantage through confidence in your security. And finally, it really helps that what Dan, our keynote speaker, is going to be speaking about, one of his themes is simplicity. And I think if you think about the complexity, speed, and the advantages of simplicity, you'll start to see that there's a framework we can use to approach these issues, right? They're not insurmountable. We have strategies. We can do this. But it's important that we don't get distracted along the way. Okay, so before Dan Kaminsky, longtime Black Hat speaker, gets up here, I'm going to introduce the longest time supporter of Black Hat and sponsor, Philippe Courteau from Qualys. Now, it's interesting because Qualys has been sponsoring Black Hat for so long at such a senior level. I'm introducing him at every conference everywhere. So I know Philippe pretty well. The interesting thing, though, is Qualys was a SaaS model before there was a cloud, but they were really SaaS before they were SaaS. And I was asking Philippe about that, like, how does it feel to be the pioneer before they had an acronym for SaaS? How did you even know you wanted to do that? And he said he got a lot of pushback because nobody was thinking that way back then. But he believed in the architecture. He looked at the architecture, he came up from mainframes to minis to micros, and he could see that the direction things were going, it was going to be internet as pipes, endpoints, and a big smart middle. And that's what was going to happen. And so he positioned the company, maybe a decade too soon, into that model. And now it's really paying off. Now he was really seen as one of the pioneers of cloud before cloud. So it's my pleasure and honor to reintroduce to you Philippe Courteau. So Philippe. Yeah. Thank you.
Thank you, Jeff, and good morning to you all, and welcome to Black Hat. It's really a great pleasure to be with the Black Hat community. I think it's a very unique community, and Today I have the pleasure and privilege to introduce our keynote speaker, which is someone that really doesn't need an introduction. This is somebody we all know for his passion and talent to uncover security flaws in the internet, and as importantly, to devise ways to really fix them. So I'm going to tell you maybe something about him that you don't know. He applies the same passion and talent to other things. Like he realized that he could help colorblind people to see colors. And he put his mind, talent, and passion to resolve that problem in such a way that it becomes very easy for blind people to see colors. And he did that by building apps on Android and iOS that now anybody on the planet can download. So you will see in his speech that same passion and talent to address the problem that is facing our community, which has been essentially said as well by Jeff, which is today we're entering an era where complexity has increased drastically, and the velocity as well. So this requires that we think in a very different way. And with that, it's a real great pleasure for me to introduce Dan Kaminsky. Thank you.
Thank you so much. Holy crap, look at you guys. Wow, we live in the future. I don't know. I've been coming to Black Hat for like 16 years, and I think like security is a big deal now. Like something's changed. Thank you, Jeff, for your intro. You're not kidding about the importance of speed to decision makers. I started a company and make decisions, and I went to go ahead and get a bunch of servers, and it was like 3 months later, and I had no servers. And then I went to the cloud, and it was 3 minutes later, and I had a whole bunch of servers. So, speed has totally changed. What became months becomes minutes. Everything's different. What you can build, what gets broken, even without, hackers showing up, believe me, and how long we have to learn and adapt from our experiences. Our cycles have just gotten so fast. And our need to make things secure and functional and effective has just exploded. So, that's the world we live in. That's going to be fun. Before I go ahead and launch into my actual remarks, I'd like to show you something. So last year, was anyone at my talk at DEF CON last year? Awesome. Yeah, so I thought it'd be a fun idea to go ahead and dive into Chrome because, why not? Before I launch to my remarks, I'd like to show you something special. Been hacking into these browsers, been putting in new features, and I wanted people to go ahead and see what I had done. And the key of the web is that you don't have to go ahead and install anything to go to a web page. Nobody wants to install anything. That's why, and no one realizes, the web is the most popular software distribution platform on the planet. But here I am, and I want to go ahead and show people some new features in web browsers. I know they don't want to install anything because they're using a web browser. So I go ahead and say, okay, this sounds like a job for the cloud. I'm going to go ahead and I'm going to host a web browser in the cloud. I'm going to show my buddies this. So here we have, I think it's on screen. If it's not, it should be. So, we have our copy of Chrome. And inside of Chrome, there's some more Chrome. And it's a full browser. You can go ahead, you can go places. It's actually really impressive how fast applications stream over the net. Now, I'm talking to my coworkers, my friends, I'm showing people this stuff, and I just want to brag about all these cool features. I'm like, listen, I got the graphics engine backported into the graphics model and the security engine. Everything's talking. And by the way, I got forget sandboxing. Can we just agree sandboxing is the worst term in the human language? So sandboxing is supposed to imply that nothing can go ahead and do anything bad because it's in a sandbox. A sandbox is the thing you put kids in. They walk in, they walk out. We don't talk about what they do in the sandbox. This is a terrible term. Isolation technology. So I want to talk about all this cool stuff I've done. This thing, the environment you're seeing that's streaming over the cloud, it's got like Chrome and it's sandbox. It's got like X running, it's got Java. It's also got my isolation technologies, and it's taking 14 syscalls. Turns out you can actually do stuff to isolate technology, just not the way we've been doing it. So here I am. I want to explain all these fascinating things, how I stopped all these attacks and built all these things. And my friends could not give the slightest crap. You know what their attitude right now is? They're like, oh my God, it's like a browser. I'm going to go to all these pages that I've always been afraid to go to. We have this joke. There's no such thing as the cloud. There's just other people's computers. We think that's like a bad thing. No, like everyone I show this to is like, cool, here's a web browser. Like, let someone else's computer get hacked, not mine. They were finally fearless. And that was my first exposure to what's happening in the real world. We're in technology. We're used to this stuff. People who were into cars were used to their cars breaking down. The real world people are getting freaked out. The NTIA just reported half of all Americans are backing away from the internet due to fears regarding security and privacy. I just seen this fear lifted. I'd never known that it had actually existed. Let's get my screen off if it's already on. So I always believe it's important to get your asks out and get your asks out up front. We have work to do if we're going to go ahead and get the internet fixed, because we're risking losing this engine of beauty. So here's what we want. Here's what I want anyway. Raise your hand if you consider yourself like a policy person. Like that's your kind of view of the universe. Well, if you're not a policy person, you certainly know a few, or I hope you know a few, and I hope you go out and find a few, because they're coming for us, people. Policy people, individuals are doing extraordinary work. We don't have the guy who works on cancer, okay? We need institutions. We need systems. We need something like the NIH for cyber, and it needs to have good and stable funding. Engineers. Possible is not enough. We have so many solutions in computer security where it is possible. If the stars align and you have the genius there, maybe you won't get hacked for a few hours. That's not good enough. We have to do better. Possible is not enough. We need easy. Start with isolation, something that I actually didn't think was possible. We have our architectures. You view an architecture diagram, and it says, data comes in, it goes, and it goes, and it goes, and you're done. And we don't say, okay, well, the next time that happens, how did the first time affect it? Well, it doesn't. Are you sure? Because the answer is never no. So let's figure out how to actually make a lot of what we do in computer security, by the way, is we make computers act like people think they act. Let's make the truth actually true. Managers, release your code. It's okay. We don't compete on security. Beyond not competing on security, your people write something today. You want it around in 2 years? The most effective archive of that code is not inside your company. It's out there, and then people are going to Google for it, and they'll find it, and the problem at your company will be solved. And what I have to say to everyone here, there's a lot of bad ideas out there, and they're coming for us, from coworkers, from vendors, from governments. I am not here to give you the answers, but I am here to encourage every single one of you to notice what is wrong and notice how it can get worse and do something about it. I want you to have better ideas. I want you to have better ideas than me. I want you to hear me come up with something and be like, I knew better than that. Because you might have a perspective that I don't. Look at all of you in this room. Look at all the perspectives. Look at like over a man-year of thought that's going into the words coming out of my mouth. You guys, some of you are going to have some really good rebuttals. Go for it. Do it. Do better than me. I will equip you as best as I can. So let's go into the meat here. We could lose this internet, you know. Like, it's not like a guarantee. It's some rule of the universe that we get to keep having all this fun. A lot of other realms have been regulated into destruction. We make promises in technology, okay? And people are starting not to believe them. The Internet of Things. Technology did not come out of nowhere. It is the natural culmination of a whole bunch of trends, not least of which the high end keeps getting higher, the low end, actually, that keeps getting higher too. The Internet of Things is the first technology people are assuming to be insecure right out the gate. I mean, they're right, but like, you know, usually we don't notice so fast, okay? For the most part, anyway. But yeah, you think smartphones were great when they first came out? Most of them aren't very good even now, and it's been a while. Okay, usually though, a new industry gets some time to get its act together. Those days are over. People are realizing what's happening here. And I worry. I worry about developers' ability to innovate without their creativity being smothered by security concerns. I worry about not knowing what to teach people. They come to me and they say, okay, we get it. We want to build the secure XYZ. What do we do? And I'm like, I don't know. And people who say they absolutely do know, no, they really don't know. And by the way, you know, a bunch of people are getting hacked. Is someone going to do something about that? You know, we're a motley crew, InfoSec, hackers and researchers, engineers and operators, managers and not nearly enough technical writers. I know some of you just like breaking things, and let me tell you, I'm okay with that. Really. You like breaking things, I like breaking things too. I do that myself. Defense minus offense is just compliance. It's like a list of check boxes. Everyone looks busy, but the house still burns down. So go break more things. Do it. Keep us honest. Keep me honest. Break things faster. We have a problem with hacker latency. It's like something comes out and 5 years later, someone's like, oh yeah, you look at it funny and it runs code. Face recognition's nothing. But there is more though. There is more to InfoSec than just blowing things up. At some point, the sec part does mean security. When you get down to it, we are the ones that disbelieve the lies, the myths, the layers of abstraction that computing is based on. Has to do it that way if it's going to work. Don't make it true. Our powers here, our abilities, our perspectives can go in the other direction. It's not just that we can make stuff fail. We can tell better stories. We can make better myths. We can design systems such that they're not just convenient to the implementers, like, well, I need that buffer to be there, that is actually following the security model that the user expects. So many systems go wrong because of surprise. And so many people think there's nothing that can be done about that. They get wrapped up in what we like to call security nihilism. I'll tell you, IT's in trouble. IT knows that it's in trouble. And they're looking to us for help. So, people looking to me for help, huh? Let me tell you guys about the time I really screwed something up. So, it's about, 10 years ago. What, do you think I'm going to get on this stage and not talk about that gigantic hack? Anyone here remember Sammy is My Hero? Oh, no, this was 2007. This was like entire months before that whole DNS mess. Jesus, things that happen in your life that make you a homework assignment. So, look, It's 2007, and at the time, MySpace is one of the internet's top 10 websites, a major competitor to Facebook. MySpace was unique, really did something that no one else supported. Random people could just copy and paste little snippets. They didn't know really what they did, but they would make cool things happen to their websites, to their profiles, and make them, really just change in all these expressive ways. So my buddy Sammy, legendary hacker, one of the few other amazing packet hackers that I know anywhere. Well, normal people want their pages to be normal expressive. Sammy is special. He wanted his page to be special expressive. Not just pretty pictures. No, Sammy wanted some JavaScript to run on MySpace. Now, this is dangerous. The whole problem of, read all these private messages from people. But no, it's Sammy. He just wanted to be your friend. So you'd visit his profile, and he'd become one of your top 8 friends. It would say, Sammy is my hero. And just for kicks, if anyone went to your profile, having been suitably transformed, their profile would also get Sammy as your hero. And so on, and so on. And I quote, oh, this is exponential. He'd made a worm. MySpace survived for hours. So, crap. So I knew Sammy. I knew the officer that had to go arrest Sammy. He called MySpace the morning. He's like, I'm sorry, I took down your crap. They worked out a deal that was okay. Sammy had not done anything hostile. But I don't know if you noticed, the rest of the internet is full of jerks. And there was a bunch of really private information that could be lost. So, what am I going to do about this? Call him MySpace. And I'm like, hi, can we fix your problem? If there's one thing you learn as a white hat, it's that sometimes you can just ask. They might say yes. They totally said yes. I flew down to LA, showed up all right, let's go ahead and make sure this Sammy thing never happens again. So, sit down with their team, look at their code. It is exactly like I thought it was. Anyone here know what a regular expression is? It's code for bad idea. It's the worst syntax of anything short of a language that I literally can't say the name of on stage that begins with brain. And does not look significantly different. You can't spell syntax without tax. So they had this filter. Regular expressions are designed to be able to filter text. And they were trying to use it to remove... They wanted to allow graphics, but not allow JavaScript. Not only was this filter vulnerable, it was guaranteed by the fundamental mathematics of computer science to be vulnerable. This is the conclusion of one of my friend's research topics called language theoretic security, or LangSec. Meredith Patterson came up with this. 2 years previous to this, he actually gave a talk at Black Hat about a thing called dejector that would go ahead and in a language-aware fashion look at SQL, major database language, and go ahead and say, is someone trying to exploit this database? So I'm like, okay, well, that was a cool talk 2 years ago. I wonder what happens if I take these tricks from Black Hat and I put them on one of the largest websites in the country running some of the dirtiest HTML in the universe. Would it work? Would it be accurate enough, fast enough, easy enough to tweet? Turns out fundamentally sound engineering is fundamentally sound. LangSec totally worked. It didn't matter how we tried to sneak the JavaScript in, it just wasn't getting in by design. Now, pretty pink ponies, cool. Super extra sparkles, got it. Comic Sans MS, no problem, absolutely, you go user. Don't judge. Don't judge. This might actually have been a ton of kids' first exposure to the very concept and magic of programming. I don't know what this blob of stuff does, but it makes my profile cool and all my friends are complimenting it. I'm going to figure out what it does so I can make it do even cooler stuff. This is awesome. Nobody ever learned to code in order to write the next great database abstraction engine. Jesus. Okay, so I told you, screwed up, right? Might have had a bug. So we're filtering HTML, right? Like the basic language of web pages. Some tags are safe, some are not. We had to list the safe ones and block anything not on that list. Now, the tags follow a particular format. Less than B starts a bold tag. Cool, nothing bad's happening. Less than I starts italic. Okay, still good. Less than image, div, object. Now, these tags can be dangerous, but we went and looked inside, and we're like, we've got the attributes, we got the types, we are diving in. We know exactly what's happening here. If we don't know it, it ain't happening. We are good. There's one thing we missed. Actually, no, we didn't miss it. Our library, our dependency, the thing we've included missed it. But that's not besides the point. That's kind of the point. It doesn't matter who wrote it, mattered we shipped it. HTML tags do not actually begin with less than and a letter or a number. It looks like it, but no. HTML tags must begin with a letter. Duh. It says right there in some spec somewhere that I don't actually know was written in 2007. Less than a letter is HTML. Less than a number is just text. Who here sees exactly where this is going? So, less than 1, less than 2, less than 3 is not some random noise that is harmless to remove. In internet parlance, less than 3 is a heart, and that, my friends, is the day that I broke every heart on MySpace. So, let's talk about this little adventure here. Slightly bumpy launch aside, we replaced what would have been months of increasingly janky and fragile filter whack-a-mole. And raise your hand if you've ever played that game. Because, yeah, right? You know that game. It sucks. Version 30. I think I got the regex right this time. No, you didn't. Guaranteed to fail. We got it replaced with a comprehensive fix. Now look, I got a little bit of issues with programming languages that are mathematically correct but are totally hideous, obtuse, theoretically correct but operationally difficult. That is not helpful. But, man, mathematically correct is a force to be reckoned with. And mathematically doomed is not a nice place to be in the world. We did not build the academic solution. We built the correct one. And the really interesting experience was realizing, wait, there's something here. It just always gets expressed badly. Bugs are not random. We wish we had such a reliable source of entropy. Hey, Bob, write some code. The random number generator's stuck. No, fixes are not random either. I knew exactly what MySpace had done here. And that's a little unusual because I was like 3,000 miles away in a German hacker camp. How did I know so well that this was going to be the problem here? Honestly, because at some point, everyone Googles how to filter HTML, and the first hit on Google is always some regex. Why is that? Really? Well, I don't know. We didn't release our code. Like, why should I expect anyone else to have released theirs? Like, what would have gotten upvoted higher? Basic frameworks by default are not including this sort of filtration. And it's an interesting question why. And I'll tell you, like a month ago, one of my friends was like, hey, I've got this site. Can you see if it's vulnerable to stuff? I'm like, I wonder what happens if I throw in one of those old things. Boom. The exploit in like 30 seconds. We're not taking all of the lessons that we have to deal with and actually dealing with them. You know, I remember speaking to a group of bankers, and I'm like, wow, you guys are like sharing all your internal secrets with each other. He's like, yeah, we don't compete on security. If one of us gets hit, we're all going down, so we should probably share our information. Managers, all of you at some point have put someone on some task to go fix some security problem. That task has probably been fixed 1,000 times. So maybe we should start actually releasing the code that we're doing. You're not competing on security. And as I kind of mentioned earlier, the best way to make sure that your code actually, like the solution, the right solution, shows up on Google, because, by the way, internal networks are the internet without Google. Everything's by rumor. Like, if you actually want your coworkers to be able to solve problems not repeatedly, it might be cheaper and cost-effective for you to just give it to the world. In other news, this is why so much code shows up on GitHub. It literally is cheaper to bounce off GitHub than get something 3 departments away. You don't compete on internal security, but man, those ads would be hilarious. I totally use PGP with my coworker. The real thing to realize here, as much as I'm saying, hey, let's release our code so it's out there, is that there's no mandate anywhere to do it right. There's no building codes for building code. That's just the deal. There's no one to appeal to. No judge that can ban flawed software. I have a thing where I don't say the internet. I say this internet, as if there could be others. Because everyone who's ever built large telco systems figures out, wow, it'd be really cool if everyone else was on this because those guys are having a terrible experience. Every generation tries to invent the internet. Ours actually did. Minitel. Anyone know about Minitel out in France? Okay. Minitel shows up early 80s, managed to fund getting these computers on every normal person's house. It's online news, weather, shopping. There is no reason why Amazon is an American company. Minitel and the French economy had it 20 years early. 20 years of advantage, gone. Okay, those guys weren't making nothing. They were making €1 billion a year in 98. 9 years later, 100 million. Shut down the system 2 years later than that. AT&T used to have these ads. By the way, what we call AT&T is not like AT&T. Actual AT&T died, and it's just the kid putting on the dad's code. Surprise! AT&T used to have all these ads, will you have video calling? You will, and the company that'll bring it to you is AT&T. Half right. AOL was literally set up to be the company that brought America online. When you get down to it, they did 2 things amazingly. First thing they did was actually make it really easy to get online. I do a lot of talking about the value of not just possible, but easy. You know what? AOL made it easy. It's gonna work. Whatever QA team they had were like superheroes from another dimension. Amazing. The other thing they did was a glorious exploit against American telecommunications law. They just sort of did the math. They're like, if we just have phone lines near it, close enough to everyone, they don't get metered. So let's just buy $1 billion worth of phone lines, and now we're done. We are not paying by the minute. No one is. And our customers can be online. We can have America online. And it totally worked. People really thought they were going to be the internet company. We actually did have, at one point, a centralized Ma Bell phone company. At least the big 3 broadcast networks. And, they got to merge with Time Warner, a company that, makes actual content like Batman versus Superman, real value. They got on top. Steve Case was CEO. The first bubble was weird times, man. Now, how did all these companies that had these huge leads and massive amounts of capitalization, decades and billions, how have they all become irrelevant? Well, not just irrelevant, how did they all lose to this internet? It's important you understand this because this is what we're defending. This is what we got to keep working. They saw the future. It was pretty obvious where things were going, but they tried to change it just a little. They're like, well, because we see the future, we want that, but with us in charge. Small little difference. Totally broken. They all tried to become kingmakers and gatekeepers. This internet won because it actually was really designed to have nobody in charge. That's the idea. We just want to, I like to joke, the internet's not designed for security. The internet is designed to move pictures of cats. It's really good at moving pictures of cats, but it was not designed to make anyone billions of dollars. And all of these guys got distracted by that concept, by becoming the kingmakers. I tell you this because it's why this internet worked. You cannot imagine how many people want there to be someone in charge that they can call up and be like, take that down. Want me to call and be like, hey, I don't want any insults for this king. Only compliments. I am boss and you're a nerd. You make it happen. I don't care how it works. You just make it happen. There is actually a company that regularly receives phone calls just like that. And that, my friends, is a place called ICANN, which my good friend Jeff Moss has actually worked at. That's their job. Their job is really for people to think that they run the internet. They don't. But it's okay. It's cheaper to have everyone believe that. ICANN runs a couple of small databases that say things like, if you would like to reach somewhere in China, here is the server for all of China. If you want to mess with me, the only thing that I can do differently is mess with all of China at once. I don't recommend doing this. ICANN's job really is no as a service. They say no to incredibly bad ideas by the most powerful organizations on the planet that literally possess nuclear bombs, with the only thing in the world more powerful than nuclear bombs: bureaucracy. That's what they do. They'll never admit it. I did not warn them that I was saying any of this. It needed to be said. Look, no arrangement is perfect, but have you considered ICANN's cut from Apple.com or Microsoft.com or Amazon.com? Like the amount of money those domains have made versus how much ICANN's gotten? Like nano pennies on the dollar. This wasn't the plan of Minitel or AOL, and they're gone. Meanwhile, ICANN's operating this DNS thing that's been around for 25 years and is literally the only part of the internet that you can make software-level design bets is going to be around 25 years from now. Tell that to all the people who miss Google Reader. I swear, they will just talk to you about it for hours. The internet does not allow much for fine-grained control, and that's the idea. That's why we still have it. We're able to swap components in and out. We're able to swap what's broken with what works, move from T1s to T3s to OC192s to just screw it. There's just packets in the air. We've replaced air with SYN packets. I don't know, it's next year's floods. This internet goes through generations of technology rapidly. It's roughly global worldwide. It does what its users want it to do. Browsers do not run little checklists to make sure that the king is not insulted. We're allowed to use encryption. We're allowed to fix encryption. We're allowed to find bugs. We're allowed to fix them. People have tried to change all of these things. I know because I've heard them suggest it. During the SOPA and PIPA fight, there was a presumption that surely there was somewhere where someone was in charge that they could go mess with and get whatever little Piccadilly thing that they wanted. And every network that gets that property where there's always just one little thing they want descends into horror. Even our internet. YouTube finally went ahead and turned on encryption for all sorts of their traffic. You know what happened? Piles of their bugs went away. All these random little people, even on this internet, were like, I'll just optimize a bit. And it broke stuff. It always does. The internet that survives does not have this sort of filter. AOL does. Minitel does. Go ahead and put Chrome. If Chrome had a filter in it, you know what we'd do? We'd go find another host for Blink. We'd go find something else. Given the existence of a network like this internet, every other network becomes at best a route to it. It's what makes this present obsession with the encryption debate so terrifying. It's not merely that we have like other problems going on with computer security. The fact that everyone's arguing about this little chunk is a signal to the rest of the world that says, hey, this freedom that those Americans were defending for so long, yeah, they're kind of done with it too. We can go ahead and do whatever we want. And I tell you, they all want to go ahead, split this thing up. There's like the Russian IP space, the American IP space. Like, this is just, we're abandoning the vision, which is kind of sustaining the largest companies in our economy right now. The world's major cloud providers are all based in America. If we'd not had SSH, the crypto wars had not resolved well in the first place. These clouds wouldn't have happened. Because you have two choices. We used to use Telnet. Either you have an encrypted channel to the thing that is literally running your business, and that's how you have secure access to it, or it's in your building, it's on premises, it's behind closed doors, it's literally the computer equivalent of putting the dollar bills in your mattress. We could have had that computational reality. It would have delayed all of this economic growth that we've had for 20 years, and we'd be in depression. And it would suck. A lot of other countries are seeing the stuff that we're doing, seeing the behaviors that we're having, and they're saying this is an opportunity to make it illegal to send your data to an American cloud provider. And that's kind of terrifying. What you end up with is, what are the costs of getting anything deployed? I put something on the internet, it works across the world, I'm done. I'm spending my time, I'm spending my money providing services for users, as opposed to the alternative, which is either A, abandoning users, or B, having a huge squad of lawyers figure out what I'm allowed to do to this place or that. This internet does not have that property. Most variants do. Most variants are giant piles of lawyers every time you want to make a move. And it's just not very economically interesting. So, listen. Not that our internet can't change things. We do. Like I said, we keep updating stuff all the frickin' time. It's just, we don't change things by mandate. We change things because they're better. I'm not convinced in either direction on the value of software reliability or mandatory standards, except to say now is not the time. I do think, however, absolutely we can invest in better environments that have more properties that we like, okay? Our cities used to burn, like every major city, Seattle, San Francisco, New York, London. If you're a major city and you don't have a great fire in your past, you're probably not a great city. Like, I don't know, growing pains, rite of passage. They didn't heal the ill by making sickness a crime. We actually studied the problems formally. Learn to deliver safety. One thing about the internet, one thing about software is just how young it is. Humanity's been building stuff for thousands of years, and we've been getting sick since before we were human. So, we have experience with that. This whole software thing's a little different. So I want something. I want something like the NIH for cyber. I want an organization dedicated to the extended study of our field that can fund and implement the hard and extended, sometimes really boring work that fixing all these problems is going to take. I want to actually inject something into my talk right now because it just impressed me this much. You all know the organization NIST, National Institute of Standards and Technology. They got this random group in there called SAMAT, S-A-M-A-T-E, and they did the greatest scut work I have ever seen. They went ahead and they collected variants of every single vulnerability in C and Java, and there's like thousands. And they went ahead and made it so you could compile them into one program. I didn't know you could have a 75 gigs of RAM make process happening. But they actually put it together. They're like, okay, there are people out there who are making static analysis tools. They'll go ahead and go through a binary and look through stuff. And it's a pain in the butt to get samples of everything. People need a corpus. People need a body to learn from. So let's make something that makes that body. And for goodness sake, they did it. And I tell you, that stuff may exist in the bowels of Microsoft or Oracle or any of a number of companies, but it was NIST that got it out the door. This is what appeals to me, okay? You know, I'm one of the DNSSEC key holders, and Doug Mon over at DHS spent 10 years carrying the torch for that thing. I don't know what I'm doing tomorrow. Okay, so there's something to be said here. NIH, though. I don't really like the immune system model that some people have. If you actually know anything about immunology, the immune system's kind of terrible. Just barely kills more of the stuff it should versus the stuff it shouldn't. Just kind of runs around, causing chaos. It's a terrible analogy for hackers. But I do like the medical model because, we did not invent the phrase snake oil. People took actual snakes and made them into actual oil. And that is where the phrase comes from. So society needed to deal with the fact that there were a bunch of solutions to problems that everyone had, and we didn't know which ones of them were total scams. And they did it. They pulled it off. You actually have a bunch of pharmaceutical chemicals that have real effects that have been shown. You have to be careful with analogies. Nobody wants the innovation problem that we have in the pharmaceutical industry on software. But the thing with pharmaceuticals is they affect humans. And we kind of are annoyed when they die. We're totally cool with processes dying. We can take the processes for medicine and run them on software, and a lot of it's the same. By the way, there's a quote, if the problem was curing cancer in mice, we'd be good. Problem solved. That has me thinking a lot lately. I think a lot about this thing about the germ theory of cyber. Now, this is like an egomaniacal phrase, but hold on for a second. There used to be a lot of controversy about the nature of infections. And I mean, it was super contentious. People died, whether physicians could infect as well as heal. Doctors are gentlemen, and gentlemen's hands are clean, was the great quote. I don't know if I'd say developers are or aren't gentlemen, but I will say the nice thing in the last 10 years is every dev is like, okay, sometimes my code gets stuff owned. It happens. It's not an impossible thing. What I think is interesting about germ theory here is it really does create a focus on how does stuff move and how does stuff store, persist. Because that is actually the right way to look at a lot of security problems. How are you taking data in from the outside world? How are you parsing it? Is your parser language theoretic correct, or are you screwing this up? Are you having imbalances? How does the infection move? Doesn't matter if the infection evolved for millions of years or whether it was something created by a human, the pathogen is a pathogen. And then when it gets somewhere, that somewhere wasn't a known good state. It's going to get infected. Do you have a way of disinfecting or not? That thing that I showed you at the beginning of this talk, I call it autoclave. Anyone here know what an autoclave is? You got a scalpel, you cut something, it's going to have a bunch of germs on it. You put it in there, it heats it up, no more germs. So how do we get that piece of metal back to the known good state? Getting back to known good state is not just a thing we want for medicine. All right, so what I want to talk to you guys about. I do want to say this. A lot of people think that programming is math. Well, I'd like to point out we don't call them programming equations. We call them programming languages. Programming is a transformation of intention into instruction. And the reason it's not math is because ground truth, the actual correct reality, is not in the instruction. It's in the intention. Because guess what? Like when someone says it's doing it wrong, you can't be like, that's what the instructions say. It's like, get out of my face. So we're headed towards a really interesting future where a lot of people are starting to program with speech. And what I mean by that is they're just telling the computer what to do, and it's coming up with a sequence of instructions to do it. There's Alexa, there's Siri, there's Cortana, there's Google Now. All of these things are about to become very different environments as they stop just exposing public data and they start actually having personal information, which Siri actually has some of, and business intelligence. For the love of God, when I can say, tell me last quarter sales ranked by employee, and I get an answer, that is the most valuable thing computers have changed to start doing in a very long time. How the heck are we going to authenticate that? Man, you can spoof voice so well. There's a huge challenge in figuring out what is going to happen as programming makes this move closer and closer to really how we ask other people to do things. The most interesting thing going on in programming, though, and I really want to get this out, is the advance of, this is rather obscure, everyone knows about LLVM, or not everyone, but a lot of engineers. Not nearly as many people know about truffle and grawl. These are environments which have made it vastly easier to create new programming languages. I told you that programming has the ground truth in the human, in the intention. We have a lot of people who are writing insecure code. That's just the nature of the beast. What patterns in what we are asking developers to try to do, to try to understand, to try to comprehend, to try to execute on, which ones are working and which ones aren't? When a user learns X, what is the security result Y? We have kept as a constant the language and forced humans to adapt. As it's becoming easier to alter the programming languages, we can go the other way around. We can figure out what people are good at and go ahead and actually give them the resources they need to express their intent properly. That's what you get when you view the hierarchy correctly. Let's go ahead and modify people or machines. People are harder. And languages matter. There's a joke. ASN1, it stands for it's a network protocol or language. ASN1, not one safe implementation. It's true. It's kind of a train wreck. But it's only a train wreck in C. Like every other programming language is actually okay because almost every other programming language is memory safe. It doesn't have the kind of problems dealing with memory that C does. So why does everyone keep using C? And it's important to ask the question because the answer is predictive. We want to predict where there's going to be vulnerabilities. You got to look at what actually goes ahead and creates them. It's like, well, I use this super dangerous language because... Who asks the question? Well, because of performance. Maybe that's the answer. Maybe the answer is because I'm embedding it in somewhere else, and I can't embed Python, and I can't embed Lua, or I can't embed this, and I can't embed that, but I can and know how to do C. We know that what we've ended up with in the way that we build internet technologies is reliably, in some places, generating okay stuff, and other places not. This is what it means when you're presuming that the Internet of Things is a train wreck. What you're saying is that there's a bunch of patterns that we have that don't work. So, the last thing I want to talk to you about is about where I see the patterns of software development going. That demo that I showed you at the beginning of this talk, that environment that you're all going to get to play with at some point this week after, I get some time to sleep, that environment lives in the cloud, and it moves all the risk out there. How do I manage that risk? There are two things that can go wrong in the cloud. One is that two virtual machines running at the same time can mess with each other. The other is that some previous instantiation of this virtual machine messes with me now. So I can be modified spatially or temporally. Someone else nearby, someone else from the past. How do I manage that? Well, the first question is, do I trust the clouds to keep this problem under control themselves? Which universe do we live in? The clouds can be trusted or the clouds cannot. And the answer is, I don't know. And nobody does. So I've got this great thing, and it's demonstrating future of clickjacking protection and web browsers and whatnot. I don't know am I actually exposing people to risk by go to my stuff in the cloud? So how do I resolve this conflict? Simple. I'm just going to engineer for both realities and see what I get. Reality one, I can totally trust the cloud. They got this stuff on lockdown. And by the cloud, I mean whichever cloud I happen to be using at the time. I know there's a bunch. I know that each of them have different modes. It's not like some monolithic the cloud company. There's a bunch of suppliers, Amazon, Microsoft, a lot of these guys. Let's assume we can trust it. Well, the easy thing to say is, well, then just go ahead and run your VM in the cloud. You're done. Move on with your life. If I can trust cloud providers to go ahead and have secure isolation, I should be using that secure isolation a heck of a lot more. Listen. We have our advice that we give people about password databases, and we tell them, when your password database is compromised, be sure that your passwords are hashed using the strongest available cryptography that you can, and we've had these competitions to see what that's going to be. Yeah. Cryptography can make something take a second. That's the limit. It's not a crypto limit. It's not a security limit. It's a usability limit. When you go ahead and use cryptography to survive a key compromise, you're saying you're going to go ahead and make password validation that could go really fast in a nanosecond, you're going to make it take up to 1 second. Any longer, and it is now no longer valuable as a password database. Well, an attacker with a 1 million node botnet can now go ahead and test 1 million passwords a second. And that's enough. And that's all the crypto can do. So it's good advice, but it's not like, saving the world. What would be really nice? It's really hard to crack? A password database you don't have because you didn't lose it. What is this defeatist, you're going to lose your password database stuff? It's almost like people think if one of your servers is popped, clearly all of them are going to be. Actually, that's sort of true. So what if you didn't have a server? See, we live in the future. We live in 2016. You can go ahead and tell Amazon, I'm really bad at running servers. That's because Amazon realized a bunch of people are really bad at running servers. So fine, just give us your code and we'll deal with the hassles. And you can just ask us to run it little bits at a time. Go ahead and put your passwords in that. And that little thing, that little function you make that doesn't have a server, it's got 2 verbs. 1, I got a new password for you to remember. 2, is that the same password as before? There is no 3, dump the entire database so this can go online and hack some stuff. That verb 3 is not implemented. You just have 1 and 2. So this pattern, where you take your sensitive stuff and you put it somewhere else, this pattern actually is pretty deep. Okay, SSH can store SSH keys somewhere else. TLS, you can have your keys on another machine without having a hardware security monitor. I don't know, let's say you've got $50 million in Bitcoin. Maybe you don't have it, they say, well, we have our cold wallets and our hot wallets. And, so, a lot of money here, not a lot of money there. Temperature's a gradient. There's ranges. You can go ahead and build a security model that says, well, this function gives up this money at this rate and not that much money at that rate. We do not rate limit our losses nearly as much as we should. So you go to 7-Eleven, they have $20 in the cash register. They don't have the entire corporate payroll for July because that would be stupid. So that universe is a really interesting universe where you can go ahead and use the fact, if you can trust cloud isolation, use the heck out of it. Stop treating your computer like it's just one computer. If you're in the cloud, we have this hidden architectural assumption that deploying another computer is expensive, and it's not actually true. All right. Now what about the other reality? The other reality is interesting. This is where you get autoclave. The other reality suggests that you can't get virtual machine isolation from the cloud. And it's important to realize that doesn't necessarily mean that it's bad. All the major clouds are really slow at resetting you to a known good state. I told you earlier in the germ theory model, You go ahead, you build something, it's great, it's perfect, you're wonderful, you know exactly what it has. The moment it touches bad guy packets, that is tainted. And you don't mind if it only continues to touch that person's packets, but my God, you don't want to have it touch like everything, right? Because it's been tainted. You want to put it in the autoclave. So if you wanted to do that in Amazon, it's going to take a minute. And it's the same in DigitalOcean and Microsoft and all these guys. And I can't tell you, I've literally run VMs and I think every cloud provider I can find. There's something interesting. So you can't go ahead and reset your image. You have to go ahead and run QEMU. Run your own environment. I never really understood the use for nested virtualization. You know what nested virtualization is? You're in a VM, you're like, I want to run another VM. I'm like, this is stupid. Why are you doing that? Well, I'm glad you asked. You have 3 ways of going ahead and running code in the modern era. You have a computer, you run code on it. It's not complicated. Can you always be in known good state? No, because computers are a lie. The biggest lie of any one computer is that it's just one computer. There's like 7 CPUs in your iPhone, okay? Like there's a ton of stuff going on in there. Once the bad guy has touched it, finding all the things that have been touched is not happening. Friend Swift on security was like, yep, we got like 30 Samsung phones going into an incinerator. No way to know if data's been deleted from them. She knows the score. Okay, so that's what happens with bare metal. Go to the other side, Docker containers. I'm going to tell you straight out, I love Docker. That thing that I showed you earlier is running in a Docker container. Takes all the pain in the butt of getting stuff installed and says, we're going to put it in a little ball in a container and you can now just run it. And the way it works is if you run 30 containers on a machine, each of them think they're the only user environment talking to a particular kernel. But that kernel sees all 30, can balance load between them, it's great. Problem is, it's got to go ahead and track all this state, all of this inner process communication. You want to get back to a known good state, you want to capture that, you want to map it. None of it was meant to be like stored or anything, it's just supposed to run. So there's a project called CRIU, which goes ahead and tries to capture all of it. Tries to capture everything in a container or even a process. I have seen it work once. I jumped for joy. It never happened again. There's just too much going on. It's virtual machines. Virtual machines, actually, they go ahead and they simulate a machine. They know what all the RAM is. They know what all the processes are. I mean, the devices are because it's running them. That thing. The reason you can get a VM to a known good state is because you can get it to a known state. You can't get anything else. So what I'm doing, here's the thing that isn't very clever. I go ahead and I run a Docker container inside of a virtual machine. Big whoop. Lots of people have done that. Here's the trick. It's a lot of gunk to start up a virtual machine. A lot of gunk, a lot of dangerous stuff that you would not want an attacker to have access to. So, what do? You don't give them access yet. You let it all run. You can keep going up until the point that you run that first instruction from the bad guy. When you load the VM, especially when you load it from a memory image, it front loads all the dangerous stuff that you need. So now that you've gotten all the stuff front loaded, but before you pass control to the attacker, now you go and say, I'm going to put some firewalls on. I'm going to put some rules on. I'm going to use what's called seccomp BPF. I'm going to put the guards down. And what you end up with is, go ahead and put the screen on here. What you end up with is a full browser environment. It's running Chrome, it's running X, it's running all these things. And find me later, I'll show you the tracing logs. It's taken like 14 syscalls. It is vastly tighter than any sandbox that we've seen in normal production, and it is fully compatible. Guys, why do I put such a big emphasis on this? People think it's a zero-sum game, that if you're going to get security, everyone else has to suffer. Well, if we want to get security, let's make life better for everybody else. Let's go ahead and give people environments that are easy to work with, that are fast, that are performant. Think in terms of the milliseconds. Think in terms of the lives that you're impacting, the time that you're taking, the difficulty it is to make something scale out, not just for your own use, but for the use of the world. Like, this is the game to play. We have an internet to hold on to. A bunch of people have asked me over the last year, hey, I need to make my system safe. I need to sandbox. I need to put it in a controlled environment. I want to do dangerous stuff and get away with it. And I think normal security advice is supposed to be like, why would you want to do that? And it's like, no. Figure out what people want to do. Give it to them. Help them. And one last thing that I have 1:40 to talk about, so I'm going to give you the quickest preview possible. I've finally understood a lot of the challenges in information security by looking at another field, and machine learning, the world's worst named field because it makes everyone's afraid of machines being able to learn better at them. No one's afraid of automated statistics. Let's call it that. We know we're bad at that. Maybe the computer can figure that crap out and we'll know to be skeptical of it. You know what you want from automated statistics / machine learning? You want to learn your data. You want it to tell you if it pulled it off. You want to absorb your data, learn from it, tell you if it worked, and then spit out predictions based on other data. I have read every piece of machine learning documentation I get my hands on. None of it talks to you like that. They're like, oh, you must be a machine learning expert trying to make the great next algorithm. And that is wonderful for machine learning experts and not for users. Experts and users have different interests in their own technology. I don't mind if you just want to go ahead and work on your own stuff. But the real magic comes when you take the expertise that you've gotten in security and you translate it and you rebuild it and you reform it. You know what I did with everything I learned in machine learning? When to make something, a CSV file comes in, a CSV file goes out. Don't be afraid to take the knowledge you have and make it accessible to vastly more people. That's what I have to say.
Excellent. Thank you, Dan.
Thank you, Jeff.
Thank you. Okay, just have a quick housekeeping announcement, and then we're on our way to the next sessions. The next sessions start in 20 minutes to 10:20. Tonight, 5:30 to 7 in the business hall on the first floor is the reception, and an hour after it starts are the Pony Awards at 6:30 in the Mandalay Bay rooms B, C, and D. So I'll see you at the reception, and the Pony Awards is a can't-miss thing. So thank you very much. I'll see you around.